We're now going to configure the axis setups for an axis. This is not necessary for a machine that you already have set up, but it will become necessary if you add model movers and other pieces of machinery to your equipment. It also would be good for you to understand the sequence necessary to set up an axis if you've got a Milo or a bolt, in order to understand what is necessary to get it to work the way that you want it to work. I don't recommend that you mess around with any of your settings on your Milo or your bolt, but it is good for you to understand how they got that way. I've opened a copy of Flair here, and this is a Flair that's running a Milo, and I'm going to slide over to there, and what I've got here is I've got a turntable. You can see there a picture of the turntable. It's just a turntable. I don't know any details about it other than it is a stepper machine, and it is plugged in to my computer. And if I now go and say setups, network setup, I can see my root box, my RT14 connected. I can see my 4 data link axes boards in my machine plugged in and loaded, and I have here a thing called node 1. This is the quad stepper board that is driving my stepper turntable that we're looking at there. So that is loaded, that is connected. This is the axis we're talking about. This is called axis 1 at the moment. Let's give it something real in the way of a name. Right click, axis setup. This is an axis setup. I've got a basic setup here, I've got a controlling setup here, I've got a tuning setup here. This I'm going to call something other than axis 1. Let's call it a turntable. Good name for a turntable. It is connected on my network. It isn't connected to a link system, it isn't connected to a robot, it is a network axis. This is node 1 port 3 of that network. That's the board and port that we've plugged our motor drive into to get this motor to move. We have here an internal scale and a display scale. The display scale will indicate here how fast I can move it and how much I've moved it, but at the moment I don't know anything about it. I have a velocity and an acceleration. I have a maximum and minimum limit, which I have nothing in at the moment. This is an independent axis. It could be any number of types of axis depending on whether it was part of a machine. It might be a target tracking axis or a master axis. It could be a focus motor or a zoom motor. It could be something really esoteric and distant past called a fade dissolve. But no, this is an independent axis. This, we're going to go now to the tuning setup. This is a stepper motor. I know this is a stepper motor, it isn't a servo motor, it isn't any of these other things. It is a stepper motor. The step pulse there is set, that is unlikely to be changed. And things like trip limit, temperature limit, current limit, these all refer to servo motors. So we can ignore all this. The tuning down here also is referred to servo motor type systems, and we can ignore these. So now I'm going to go back to my basic and say, okay, I've got these display scales here. I may want to control this. Let's see if I go to control. I've got a handheld box velocity here. I don't know anything about the scale involved on the axis, so I'm going to put 5 there. Now, my handheld box speed at the moment is 100, so if I bring that down, let's go to 10 and see what happens when I go to move this turntable. I have numbers changing, and it is moving. Moving very slowly, but it is moving. So I know I can move it. I don't know how fast I can move it, but these settings I need to set up. In order to set up those settings, I need to be able to tell how much I am moving it. So let's speed up our handheld box speed and see how fast we can move it. We can move it quite fast. I could probably go 20 there. I actually need to change something there because I need to go there because there's a safety network also controlling this. So I'm going to go to 20 there, see how fast I can move this. Can I move this at 20 whatever they are units per second? Yes, I can move this at 20 whatever they are units per second. But I still don't know what they are. In order to be able to prove what they are, I need to scale it. And in order to scale it, I need to put some marks on the disc first of all. So I'm going to put 2 marks with some red tape. I'm going to put a mark on the outside edge there, and a mark on the disc. I'm going to put a line there. And I'm going to call that 0. 0 direct. Now I'm going to move it 360 degrees. Because it's a rotary table, I want to scale it in degrees. I don't know how many units that will take, but first of all, in order to scale it, I need to turn it 360 degrees. Let's just for fun store a line there, store another line there, and let's move this 360 degrees by looking at the picture. This may take a little time, but it is necessary to do this fairly accurately in order to be able to work out what the correct scale should be. When it comes to scaling an accurate robot, this is only an estimate. When it comes to scaling an accurate robot, you would go to the manufacturer and you say, what gearbox ratio have you got here? What motor are you running here? What encoder are you putting on this? And you would put that into a mathematical formula and you would end up with a number for the scale. So I'm now going to put that back where I think it is at 360 degrees. So I've just put that at 360 degrees, and because of the scale figure that I had there, which was 10, which is a good display scale to start with, it shows that I've gone 859 whatever they are in order to do 360 degrees. Fortunately, I can actually work things out. So what I'm going to do is I'm going to click on Calculate Scale, and I come up with a box. Reported distance travelled is 859.8 units. Actual distance travelled is 360 degrees. Current display scale is 10. If I click on calculate and then apply, that 4.1869726 has appeared in my display scale. If I now say, okay, that's going to be degrees, and go save, apply, then here, hey, 360 degrees. So by doing that calculation, moving the machine the required length, I can scale the move and scale exactly what that machine is doing. I have a number of different units I can use. I can work in meters, centimeters, millimeters, inches, feet, degrees, radians, and furlongs. I know nobody who works in furlongs with any machines that we make. This is a good estimate. When I build a Milo, I don't use a good estimate. I go to the designer and I say, how big is your gearbox? What gearbox ratio is it? What motor are you putting on it? What is the encoder lines on that motor? And we put it into a mathematical formula and we come up with 4.1869726. Now, because this is in degrees, there's an internal scale there. That internal scale is 0.730765, and as you can see, that is the internal scale. That's working in radians and encoder lines. So now I have scaled my axis. This is a realistic scale, and my axis velocity and acceleration and handheld box velocity and acceleration are now based upon that. So I can now move that, and fortunately this machine will do 20 degrees a second. In both directions. I don't yet know the maximum speed that it'll do. I may need to find that out. So back to my basic setup. I've got 20 degrees per second as an axis velocity arbitrarily chosen. It looks as if I can do that. Because this is a stepper motor, my acceleration can probably be considerably faster than the velocity. This is something that will depend on the machine that you are using. So if I put my handheld box, go to my handheld box velocity, say I want to put, let's see if it runs at 30 degrees per second. Oh yes, I have a warning from Simon there saying I haven't yet set up my axis to go that fast. Okay, let's go back, put an arbitrary number in here so I don't get the warning. Apply, go back to my handheld box. Can I do 30 degrees a second? Let's see. Looks like I can. Can I accelerate at more than 30 degrees a second? Let's try accelerating at 50 degrees a second. Can I do that? Too right I can. Can I go faster than 30 degrees a second? Remember, I'm working with 100% handheld box speed. Let's try going 40 degrees a second. See what this particular motor does. Apply. It's done it. Hey. Now this machine has done that, but there's no load on this machine. It isn't doing anything. If I put a 200 kilo weight onto that, about 440 pounds, it's possible that I may not get the top speed that I want to get. Let's go 50. Yeah, it'll do that. No, it won't. So 50 is too fast for it. Let's go back to 40. Seems to do 40 with no problem. Ooh, the tight spot there. Let's make it 35. I'm going to go with that. So 35 degrees per second seems to me a reasonable speed. It seems to be doing that without tripping out too often. Let's see if we can go a bit faster on our acceleration. Try a 70. No problem. Now especially my handheld box acceleration will depend on the load I'm putting on my machine. These values of handheld box velocity and handheld box acceleration that I've put here, running at 100% handheld box speed, are merely inquiries to find out how the machine can behave. So now I can go to my basic setup and say maximum speed 35, maximum acceleration 70, runtime factor. This is a safety factor that we put in so that some idiot isn't going to break the machine. 0.95. Okay, I have here a Goto velocity. This is a speed that the machine will do when I ask it to do a Goto. The pre-roll factor is the fraction of the maximum acceleration used in pre-rolling up to a hard start, the beginning of a move that is starting moving. Post-roll factor is the percentage of the acceleration that we use to stop after we come to the end of a move, or if we stop the rig in the middle of a move. So we've got these two values here. Now this particular turntable I don't particularly want a limit on, so I'm going to put in a maximum limit of, well, let's just say 2 turns that way and 2 turns that way. I've got a maximum travel now of 2 turns either way. These values you will not need to change on your Milo or your bolt, but you may well have to put this value and that value in when you have found a home zero for your track. And this is an important part of setting up your machine on track if you're going to home it and then do repeat passes, especially if you want to not run off the end of the track or run into your buffers. You need to put in soft limits, and these are effectively the soft limits that I am putting in here. Now this particular machine, it may have a magnet inside for zeroing. So what I'm going to do is I'm going to say, let's put a velocity in minus 20. That's the velocity that it's going to look for a magnet. I also know that this particular machine doesn't have end limits and doesn't have an encoder on. So there's no point going for a datum 0, because that would look for a 0 marker pulse in my encoder once it had found any magnet. I'm going to go for opto datum 0. That will use the magnetic edge as a reference point before doing some offset. I'm going to put 300 seconds in for the zeroing time, just in case it takes a long time to find this magnet. Let's apply and save that and go turntable, zero home. And off it goes looking for a magnet. I have every reason to believe that it will find one. But then I'm an optimist. Hey, that was quite a good guess. That is actually now my zero position. So I could, if I wish, put accurate marks in place. But I'm not going to do that right now. What I'm going to do is I'm going to put in an offset. This zero offset is to travel from my reference point in order to go to a zero position. Now I happen to think that I want my zero position to be just there. That's my zero position. So now what I'm going to do is I'm going to put in place my marks. I'm going to call that my offset. I'm going to call that my zero position. And of course, I'm actually 36 degrees, 0.519 off from that zero position. So now if I go left click, right click, add store, this 36 degrees there comes into my zero offset. I don't need 300 seconds in order to find home. I'm going to put 30 seconds in there. Save apply. Okay, so now if I go turntable, zero home, goes find my magnet. There it is, comes back, finds the magnetic edge, checks the edge exactly, does it go to zero position. So I've now got a zero position, I've got a zeroing speed, I've got a zeroing time, I've got a handheld box velocity. I'm going to slow that down because it's actually more useful to me to have a slower handheld box velocity for accuracy in setting up something. I'm going to put 20 there and 50 there and save apply that. So I've now got a configured axis in order to move my model mover. So that is now done, and I can go right click, axis setup, there it is. This same principle was used to get the angle correct. This same principle was used to get the pan correct. This same principle was used to get the tilt correct. All of these were done in setting up your original machine. Don't change them. Do a backup of your software and a backup of your configuration, because those values you really don't want to change. Something like your turntable, it's necessary for you to understand how to do it, but you now also know how we found out these speeds, how we set up those axes. If you really want to save those values, all of that, everything in these is saved in a job. So if I now go File, Save As, and I call it Default Configs 001, I've now got a default configuration job, and I could then make it read-only, and that way I wouldn't lose that data. This has been a Mark Roberts motion control training video. Thank you for watching.